This is our Forces in Motion title, which is part of the Forwards with Science series, aimed at Key Stage 2 science, though some of the screens are suitable for Key Stage 1 and indeed older pupils. It runs on TextEase, and that means that you need TextEase on the computer in order to run it. So if you click on here to go back to Forces in Motion from Forwards with Science. There are a number of buttons on the screen, opening screen. If I click on some of these, you can see what they do. This one here opens an information panel about the programme. This is version 3.47, which has just been published June 2012. Click on here to find out what the different buttons do that appear on the screens. If we click on some of these other buttons, that one opens an activity on magnetism, that's one on changing the shape of dough, and if we go here, we get into the Forces and Motion menu, and here we can click on any one here. So we go to hot air balloons, and then we go out of there now. And so there we are, Forwards with Science. If we click on this one, back onto here, if we click on this one, we go into the first screen on the programme, which is one on using forces. Now, if we look at the taskbar, the arrow predictably goes backwards, that one goes forwards. We know what that one does. That is the task button, that is the answer button, support button, that is the research button, and that is the resource button with words, pictures, and sentences, sometimes beginnings and endings of sentences, sometimes all three. And so the way that works, if we click something in there, as TextEase does work, and we write something in there, we have, shall we say, opening a door. Now that can be either opening a door, or indeed it could be closing a door, whichever way we decide to put the arrows. So if we say that is opening a door, we can put the arrow like so, and this one then closing a door, or of course those two could be the other way around. And here we've got some more images that can be used on there. If we go on to here, that is a totally open-ended screen, the same bar task as before, taskbar rather, and we know that this part actually is the part that would print if we printed the screen in the normal way like so, and of course we can go further down and add more information to the screen. The taskbar is movable and it doesn't print. If we want to save the work of the children as they do it, then we could do a print screen and put that through Paint and save the resulting JPEG or whatever it is in the children's folder. So there we are, using forces, thinking about forces. This is a good activity for using as possibly a homework activity on a Friday evening, thinking about all the different things that we have forces for. We could have swallowing food even, and perhaps we can put that one down as an example. Swallowing food, a little less obvious than some of them, and that of course is a pushing activity. So what we can do is either bring the square up there to show that that is pushing, or we could do it in a different way. We can go to here to find out how to do this that I'm about to show you now, and then what you do, you select the square and you go there and cell, fill colour, and we would say, okay, we will use the blue colour because that gives you our swallowing food, our pushing. And different things, we could have turning a tap, we could have riding a bike, all kinds of different things. And one at the end, then we could have quite a few different things. A good one for children to discuss maybe as a homework activity with parents, with neighbours, with each other, and then on a Monday morning come back to school and do it as a whiteboard activity in order to introduce the whole concept of forces. Forces are all around us, and this is a good activity for showing that. And here another one, everyday forces, pushing, pulling and twisting. And here again a word map. We can think of the effect of forces. I get up in the morning and I open the door, I turn the tap in the bathroom, and so on. And here we have comparing forces, pushing and pulling. And magnetic forces, the next screen. It's a nice one, the children enjoy this one. What happens when you click on magnets 3 and 4? Well, we'll click on them and find out. They can see the process of attracting and repulsion of magnets. They can put the arrows in the right place. They can go to this activity now. They can click on there, stage 1, stage 2, stage 3, stage 4. They can write their prediction, and they can then do the investigation. How many strokes of the magnet, how many paper clips are held. Their prediction may be that for each magnet stroke on the nail, it will hold 1 more paper clip. Maybe that'll be true, maybe it won't be true. It's up to the children to find out. Here, another one on investigating magnetism, and again, and here one light and gravity, weight and gravity, measuring weight and mass. Here you've got a few clues, like the baby weighs 10 kilograms, so how many newtons is that? They've got to work that out. And of course, they have a little bit of help there. And so we go through here, friction. Whenever you have a text box like that, you usually have beginnings and endings of sentences. Here we are. Friction slows moving objects down, and so on. Or the children can write what they want to themselves. And then, of course, you have differentiation by what they do by conclusion. So here we are, types of tyres, a measuring activity. They have to measure the diameter of the wheel, the depth of the tyre, the depth of the tread, and then think about the importance of the type of tyre on any particular vehicle. How friction affects movement. There are more images, drawings put there, and here you've got that leading on to investigating friction, a little bit more complicated, and again another Venn diagram. If then because. If somebody sits on a bike seat, then the springs will compress because there's more weight on the bike seat. Fine, get rid of that and say if somebody turns the handle of the handlebars, the bike will change direction because, and so on. So you can use that activity over and over again, the if, then, because. Advantages and disadvantages of friction, what we've got here is a colour-coded one, and we've got some words here. So what can we look at here? Heats up in our roads. Well, that could very well be talking about the machine there. Increased costs for the bus, and slow down by braking, or the sole wears out, obviously the sole of the shoe, and so on. And then another similar activity there. The effects of friction, what happens and why it happens. Here, how surfaces affect friction. What they have to do is move the shoes as they need to put them in the right place. And then what they do here is record the results in the table, complete the graph, and again, the graph of the force required, time taken and force required. And then similarly, they have another graph on how mass affects friction. A similar experiment, but using mass rather than friction this time. Forces in riding a bicycle, forces in car parts. Aeroplane shape and air resistance. Here's a nice little one as a simple investigation. If one group do that, and of course do the same with the arrow, and the other do that, and if they go into here, it'll show them how they can do that very quickly. And they throw them, and they work out their prediction, and they write their result down, and they compare one with the other. This one is one where you've got a slowing of the fall, timing the descent in this one here, describing and explaining. And of course you've got thermals there, as well as the mere air resistance. And of course this one, down he goes, oops, not very pleasant. And so that is a comparison between the two. Then we go to hot air balloons. What the children have to do here is to write a 5-question quiz about hot air balloons. And that is to encourage them to read what is here. Now, most of the envelope is made of nylon, but the skirt, closest to the mouth, is made of Nomex. Nomex is flame-proof, and so on. And that'll give the children quite a few ideas. And if we go to here, did you know that the first balloon carried a sheep and a duck and a cockerel high up in the air in 1783? The children will be able to pretend that they were in the crowd on the day, and they can write a newspaper report on that. And here again we have comparisons, a hot air balloon on the ground with a jellyfish out of the water, both without any support. Space shuttles, again they're able to complete the text box here, or they can go to here, hot gases, what we've got here, combustion chamber, and of course the children must remember to click on the words, not on the frames, otherwise they'll separate from each other. And here we've got one, the internal engine, hydrogen and oxygen combine, an explosion occurs in the combustion chamber, and then what happens next. Car shape and air resistance, compressing springs, extending, changing the shape of dough. Here's one here where we've got more associated words. So length and squash, bringing the two ends closer together is what happens when we squash things, and so on. Water resistance, floating and sinking, what happens here? And the children have to look at that and decide what is happening. The boat floats when, and they've got to decide from there. They can put the arrows there, and they can add to that. Once again, on and in the sea, and they've got more words in the word bank to look out for. And here, again, what is happening? Why does that happen? And here, sinking, the turning right, the floating, and so on. And there, investigating floating and sinking, and speeding up and slowing down, effect of forces on movement. So we're comparing the two types of car, what might affect their speed, And then we're getting balanced and unbalanced forces, changing direction. The ball will change direction when it is kicked, and what they can do there is investigate that in the school playground maybe, measure the angle, copy those, and once again do that activity to work the angle out, and then go out into the yard and see if they can do that same activity. And that takes us back to the beginning of forces and motion.